Hey everyone, and welcome back to the channel. Today we're diving into something that's becoming increasingly critical for anyone running Linux systems: how to defend against AI-powered cyber threats. And trust me, this isn't your typical security video. Artificial intelligence has transformed our world in incredible ways, from the tools we use daily to the infrastructure powering the internet. AI is everywhere. But here's the thing. With that power comes a new generation of threats that traditional security measures simply weren't designed to handle. AI-powered malware can learn from its environment, adapt its behavior in real time, and evade detection systems. Traditional threats are no longer the benchmark. We're talking about attacks that evolve faster than security teams can respond. AI-powered malware can learn from its environment, adapt its behavior in real time, and evade detection systems that would catch traditional threats instantly. We're talking about attacks that evolve faster than security teams can respond. It's a whole new ballgame. The statistics show a massive spike in these sophisticated attacks. The numbers are staggering. But Linux has always been at the forefront of security. Its open source nature and robust architecture make it uniquely positioned. It's about access control and unique positioning. In this video, we're going to explore exactly how to leverage those capabilities. Let's get into it. We're going to break down the arsenal you have at your disposal. First, we need to understand what makes these threats so dangerous, because you can't defend against something you don't understand. Traditional malware follows predictable patterns. It executes the same code, uses the same exploits, and behaves consistently. That predictability is what makes signature-based detection work. You identify the pattern once, and you can catch it everywhere. But AI-powered malware? That's a completely different beast. AI malware can modify its own code structure while maintaining functionality. It's called polymorphic behavior, but AI takes it to another level. Instead of following pre-programmed mutation patterns, AI-powered variants can generate entirely new code structures on the fly. Traditional polymorphic malware is like a lockpick that changes shape. AI-powered malware is like a lockpick that learns the lock and manufactures a custom key. Then there's automated vulnerability discovery. AI systems can scan networks and applications, testing thousands of potential exploits per second. They learn from failed attempts, refine their approach, and identify zero-day vulnerabilities. And once they find a vulnerability, they can craft custom exploits optimized for that specific target environment. But perhaps the most concerning capability is behavioral evasion. AI malware can detect when it's being analyzed and modify its behavior to appear benign. It might wait days or weeks before activating. This makes traditional dynamic analysis nearly useless. You can't analyze behavior that deliberately hides itself. Now, let's talk about something that doesn't even require compromising your system directly: deepfakes and AI-powered social engineering. Attackers can now clone voices with just a few seconds of audio. They can generate convincing video calls and craft personalized phishing emails that adapt based on your responses. Once inside, the malware establishes persistence. It moves laterally through your network, adapting to avoid your specific security tools, and it exfiltrates data slowly in patterns that blend with normal network traffic. And this isn't theoretical. AI-powered attacks have increased by over 300% in the past 2 years. The scale is exponential, so what do we do about it? That's where Linux comes in, and that's where things get interesting. Let's look at your defense arsenal. Linux gives us a comprehensive toolkit for defending against these advanced threats. And I'm not just talking about installing an antivirus and calling it a day. We're going deep. First, let's talk about why Linux is fundamentally well positioned for security. The architecture itself is built on the principle of least privilege. Every process runs with the minimum permissions necessary. The kernel is separated from user space, and the open source model ensures rapid patching. This separation is critical. It ensures that user-level compromises don't automatically grant full system control. At the kernel level, Linux includes several critical security features like address space layout randomization, or SLR, to prevent exploitation. There's also kernel page table isolation and lockdown mode, which prevents even root from modifying the running kernel. Now let's talk about SELinux, Security Enhanced Linux. This is where things get really powerful. It implements mandatory access control, or MAC. Unlike traditional discretionary access control where users can modify permissions, MAC enforces security policies at the kernel level that even root cannot override. In a traditional system, if malware gains root access, it owns your system. With SELinux, even a compromised root process is constrained. In practice, every process and file gets a security context. These define what actions are allowed, regardless of traditional file permissions. A web server can read web content, but it can't access your home directory. A database can't execute arbitrary code. The policies are independent and enforced. If SELinux feels too heavyweight, there's AppArmor. It uses path-based profiles rather than labels, making it easier for many to configure on Ubuntu or SUSE. Moving up the stack, Linux offers powerful firewall capabilities through NF tables. You can filter traffic based on source, destination, and even packet content. Fighting AI with AI. Modern IDEA systems like Suricata use machine learning to identify anomalous behavior instead of just relying on known signatures. Continuous monitoring with tools like Oscary lets you detect suspicious patterns. Sandboxing and containerization limit the damage. Each container has its own file system and namespace, isolated from the host and other containers. Advanced concepts like immutable infrastructure make persistence nearly impossible. The key is defense in depth. You layer multiple defenses: kernel hardening, MAC, network filtering, and sandboxing. Bypassing one is possible, bypassing all is exponentially harder. Alright, so we've covered a lot of theory. Let's talk about practical implementation. What should you actually do? Start with the basics. Enable automatic security updates. Configure your firewall with default deny rules. These are foundational steps that take maybe an hour to implement properly. Don't skip them thinking you'll do advanced defenses first. The basics catch most attacks. Setting up fail2ban and configuring access controls is vital for a solid base. This is straightforward but essential work. It's about building a robust security posture from the ground up. Next level, implement proper logging and monitoring. Set up centralized logging with something like RS-Wiselog or journal forwarding. Deploy an IDS like Suricata. Configure audit rules to track events. Logs are useless if nobody looks at them. Set up automated alerts for suspicious patterns. For production environments, go further. Implement network segmentation, deploy honeypots to detect reconnaissance, use mandatory access control for all services. Consider immutable infrastructure for critical systems. Security is an ongoing process of monitoring and adapting. It's about continuous improvement. You're never done with security, you're always evolving alongside the threats. Building a mature model is key to long-term success. So here's the bottom line. AI-powered threats are real, they're growing, and they're sophisticated, but Linux gives you the tools to defend. You just need to use them effectively. Layer your defenses and stay informed. You have the power to secure your infrastructure. Stay ahead of the threats. If you found this useful, hit that like button and subscribe for more Linux security content. Drop a comment if you have questions. Thanks for watching, and I'll see you in the next one. Stay secure.